computer. Great. So we're recording. Couple things. I'm going to share my desktop here. And we're going to try to log into Learning Suite really quick and see if we can check out the schedule. So I just wanted to make everyone aware, just so that we all are on the same page about our schedule. Remember that your first Elm Lab is due. First Elm Lab is due this Saturday. So I think in Learning Suite it used to say Friday, but we turn things in on Saturday in this class. So I changed it. So it is now due on Saturday. So if we look at the rest of the schedule, today is the last day we're going to be talking about Elm. Just going to go over the model view controller framework and try to get you ready for the lab. Lab is due on Saturday. Please start now. It's not too hard, but there'll be some learning that you'll have to do. And then starting on Friday, we're going to swing into Haskell, which is a lazy language. And then just a few weeks left of classes, really. It's pretty amazing. We've only got three or so weeks left. So we'll be doing kind of a mixture of different languages for the last couple of weeks after we finish Haskell. So, are there any questions on the schedule? If not, we'll just go ahead and dive in here. Let me just bring up my little windows. Remember, if you have any comments or questions, please feel free to break in at any time with audio, or raise your hand and I'll call on you if I do pretty good about noticing, but every now and then I don't. Okay, so today we're going to keep going on Elm. So there's a couple of things that came up last time that I wanted to clarify. First, as I was just reading through the Elm documentation, I ran into this. So you remember we talked about this little quote last time. This was Tony Hoare who said, "Oh, this was a billion-dollar mistake to create null references." And I found this quote about the quote. So in the lower right-hand corner was just a little bit more explanation from the Elm documentation about why they felt like this was a big problem. And it has to do with implicit versus explicit error handling. So in a language like C or C++, sometimes you can have pointers to objects, and those pointers can be null. And what that means is it means that you have to check to see, oh, well, did somebody give me a null pointer? That makes failure implicit. Everybody always has to check, because you can never guarantee that someone has handed you a properly formatted pointer, because it could be a legitimate pointer, but it could also be null. So it's sort of the type pointer has inside of it in C or C++ these two possibilities. There's a possibility it's pointing to something invalid, and there's the possibility that it's pointing to something valid, and so everybody has to check all the time. But Elm avoids that. Elm says, no. Take strings, for example. If something is a string, then it is a valid string, and there's no other way, like there's no such thing as a not valid string. If somebody hands you a string, then it is a string. And what that means is if I have a function that can return a string, or maybe return nothing, I have to wrap it in like a maybe type. And the reason for that is it makes error checking explicit. It means, like, if you've got a function that could return nothing, then someone's got to handle that. But the point is, every string is a valid string. There's no such thing as an invalid string. And so you never have to check for validness. And I really loved that. I was like, oh, that makes so much more sense to me. That is a fantastic point. And I'm glad that I just found this quote about the quote. So anyway, I thought that you might appreciate that. Okay, there's some questions about type aliases. So here's what I learned about type aliases. The question was, what is the difference between just declaring a new type and declaring a type alias? We talked about this very briefly at the end of our last lecture when we talked about record types. And so when we talked about record types, we pointed out that you make records using the curly braces, so it kind of feels like Python or something. So in Elm, you define new types when they are literally new types. And things like records with specific kinds of fields in them are not new types. They're perfectly valid types even without a name given to them. So these are sometimes called naked types. So for example, let's imagine that I'm writing a little program that has like a drawing program and it has a bunch of points and those points have X, Y coordinates. So let's imagine I wanted to have an add function. So I could create a little record with an X and a Y coordinate, and I could have a little add function, and the little add function accepts as input a first parameter, which is a point, and a second parameter, which is a point, and then returns as output some point. And the body of the function, if you call it add AB, will give you, unpack the dot X values and we'll add them together. We'll unpack the dot Y values, add them together, and we'll wrap the whole thing back up in a record. This is a perfectly valid function, and this is a perfectly valid type signature. So these are naked types. And this is like terrible. Like, nobody wants to write this. And so instead, you give an alias to this type. But importantly, you didn't create a new type. This is the type. And so, for example, you could alias it. So type alias, you call it, say, point, and that would be equal to this type. And now you could have a function signature for a thing called add, which is point maps, the function add takes 2 points as input and then returns a point as output. And here's the body of the function. Okay, so that's a type alias. When we create new types, we are giving meaning to words that had no meaning before. So for example, when we created the maybe type, we have nothing as one word, and we have just as another word. And those words didn't mean anything before we created the maybe type. But once we've created the maybe type, those words have meaning. So that hopefully clears up a little bit. So type alias is just giving another name to another existing type. But when we create new types, they are literally new types. Okay. There was also some questions about the either type. So when I presented this, people said, well, let's just remind ourselves. So the either type, and we sort of made this up, like I'm not even sure if anybody does this, but either AB. So remember, either is the name of the type, but it's parameterized with A and B. So A and B are type variables. And so we're saying that something is an either AB if it is a left A or a right B. And the question was, well, why do you need left and right? Can't you just have A or B? And remember that we wanted to use this and do something like, for example, create a new type called MyList. And a MyList type is a list that consists of things that are either ints or chars. And so the question is, well, why do we need left and right? Why can't we just have A or B? So we could still say either int char, and it would be either int char, and that would be equal to int or char, right? And I said, well, I think it has something to do with matching. I'll look it up. So I tried to look it up, and there's a couple things that I learned. So the first thing that I learned is these are called type variants. So everything that's separated by the or operator here. So this is one type variant. This is another type variant. And type variants have to have names. So actually, you can't type either AB equals A pipe B. It's a compiler error. Like, it won't even compile. So you have to give each variant kind of a name. And I think the reason for that is because otherwise you can't disambiguate and unpack things of this type. Let me give you an example of that. So I've created here this function called map2. And the idea of map2 is it's like map, except that it works with either lists. So in a normal map, you have a function which maps things of type A to things of type B. You give me a list of things of type A. I apply this function to everything in it, collect all the results, and the result is a list of things of type B. Easy enough. But what if we have a list of eithers, A, Bs? So now every element in our list might be an A, but it might be a B. So I created a function called map2, and the idea of map2 is you give me two functions. One function is supposed to deal with A's, and the other function is supposed to deal with B's. So let's look at the type signature of map2. By the way, I did like type this in, it compiles. I haven't actually tested it, but I'm pretty sure this is right. Sorry, I was doing it right before our lecture. So here's the type signature. You give me a function that maps A's to C's. You give me another function that maps B's to D's. And you give me a list. And the list contains things of either A, B's. I'm then going to do my thing, and the final result will be a list of things that are either C or D. Kind of cool. Okay, so let's see what the logic of the function is. So the map2 function, here's the 3 parameters. 1 function, 2 function, and the list. So I'm gonna do a case statement on the list. If it's an empty list, I'll just return the empty list. That's the base case. Otherwise, I'll do the recursive case. So here are the 2 cases. Left X means, remember that : this is head rest. So this means there's the head of the list, which is of type left. : XS means, and XS is just the rest of the list. So we're gonna pull the head off the list, and if it matches, if it's a left thing, then what we're going to do is the value of this expression will be, I'm going to take F1 and apply it to X, then I'm going to lift it into a left, and then I'm going to concatenate that with calling map2 on the rest of the list. So it's kind of beautiful, right? I'm able to pattern match on the type of the object. I can pull the object out of the left, think of it as maybe a container. Like I can pull whatever the actual X was out of its container. I can apply F1 to it, and then I can wrap it back up in a new left and then keep going. Same thing is true for right. Now, so I think this is pretty straightforward. But, so the question was, why do we need the left and the right keywords? Remember, that's what we're trying to answer. Let's imagine now trying to write this function with, if we didn't have left and right, if either AB was just equal to A or B. Well, all of this would be the same until we got down here. So empty would still map to empty, but then we'd somehow have to say, well, like we need to pattern match. So X is the actual thing, it's the actual integer or the actual character. But what would we put here if we didn't have the word left? Well, you might be tempted to say, well, X is a thing of type A, and so we should put a lowercase a here. But that's going to be really confusing to the compiler because all types start with capital letters. So there's a syntactic ambiguity. If you put a lowercase a here, it's going to look like a variable or a function or something. It's going to be this weird thing that isn't in the right place. It's not the right type of thing. And that's because type variables in a type signature look like normal variables in a function body. So I actually think, like, I'm pretty sure you can't put an A or a B here. Partly it's syntactic, but I think it points at a deeper logical reason, which is if I had A and B here, if I didn't have the function signature at all, then A and B would just be variables, type variables, but I wouldn't know that the first case corresponded to one type and the second case corresponded to another type. So it's hard to explain, but my intuition is you have to have these to be able to reference the specific variant that you care about. So it's almost like a handle to the specific variant. Okay, well, that's my best answer to the question of why do you have to have names for the variants. Hopefully that's helpful. I don't think we should spend much more time on it, but I have to say though, I really had fun writing the map2 function. Maybe that will be an assignment someday. Okay, today we're going to talk about the MVC software pattern. So very briefly, just to make sure you're all still awake, who here has already heard of the MVC software pattern? Just tell me in your group chat really quickly. John, go ahead. Oh, I see. John raised his hand, meaning that I guess you have heard of it. Okay, so it sounds like a lot of you have. Where did you hear about it? Was it 240? 340? 340 or 240? Okay, great. Oh, and work. Okay. Yeah, so a lot of you may already know this, and I've actually never been a professional web developer, so you may actually know more about this than I do. I'd be happy to learn from you. Like I say anything that's wrong, please feel free to correct me. But the idea of the model view controller, for those of you that haven't heard about it, sounds like a lot of you have, but let's review it very briefly. The idea of the model view controller framework is that it separates concerns anytime you have an interactive application. So the idea is that the model houses your application state. Whatever your application needs to keep track of, anything that can change over time, that goes in the model. Think of it as sort of like a database. The view is responsible for rendering the thing that the user actually sees. And importantly, whatever's tracking the state of your application doesn't have to care about what the view is doing. In fact, you could have multiple views all connected to the same model. The view renders something that the user sees. This is often like an HTML page, but it could also be an app screen or a frame in a desktop UI or something like that. The user then interacts with the view and generates a bunch of messages. And the idea of the controller is that it takes those messages and updates the model and changes it. And then updates to the model are reflected in the view, and the cycle continues. I think it's very important to recognize that in the MVC software pattern, it's done well. Under the hood, the MVC framework is going to be doing a lot of work for you. So the wrong way to think about this is every time the user clicks a button or scrolls a window or whatever, we rebuild the entire model and then we re-render the whole UI. That's typically not what happens. So at least in Elm, the idea is that under the hood, Elm can be doing a lot of work so that when we update just a little piece of the model, that little update triggers a small update to the view, and which maybe re-renders just a little bit of the thing that the user actually sees. In other words, you get incremental changes for free if you've got a really good MVC thing under the hood. So what's cool about Elm is because since Elm and sort of is built around the MVC software pattern, it sort of does all this for you automatically. So you don't have to worry about calculating the deltas and coming up with minimal view updates or anything like that. This is largely handled for you. Okay, so for those of you that haven't seen it, here's kind of what the flow looks like. Maybe here's a little application, like a Twitter-like application. You've got the state of your system. Maybe you've got some things that you want to track about users. Are they logged in? Have they posted anything? So you render this into some UI, maybe a login screen because they're not logged in. The user takes some action, which is login, and it goes ahead and updates, the controller updates the state. So now they're logged in. This renders a new user interface. The user does something like creates a post. This creates a new state, like maybe now the number of posts has been updated. That creates a new UI, etc. We keep rolling through it like that. In Elm, this is all reflected in the Elm runtime. So remember that the Elm runtime and your application logic are all compiled onto the browser into some tight and fast JavaScript. And it implements the update model view loop for you. So when the user interacts with the actual application, a message is generated. This message goes to an update function, which updates your model. Changes in your model then get passed to the view function, which renders new HTML, which is passed to the runtime and is rendered for the user to interact with. So I think it would actually be helpful to see this in action. So I want to do some live coding here, just to kind of help us all see how this works. So I have, we're going to change the way I share my screen here for just a second. Dun, dun, dun. I learned in my last section I can do this kind of cool thing where I can share just a portion of my screen. This makes it easier for everybody to see what I'm doing because we've found that it's kind of hard to make things, like to zoom in on things. so you can read it. All right, so first things first. So you're looking at a portion of my desktop. And in this portion of my desktop, I am here in this directory called the Elm Architecture Tutorial. And there's a couple of files in here. So this is an Elm application. And we're going to be using something called Elm Reactor. So Elm Reactor is just kind of like a little thing that helps us to be able to develop Elm applications in kind of a bare bones way. What it does is it takes your application and compiles it, and then anytime you change files on disk, it automatically recompiles for us. So just so you know, I'm running Elm Reactor kind of in the background here. The next thing I'm going to pull up is our actual code. Wait a second. All right, so I'm here in Emacs. I'm loading up our very first example application, and it's this simple, it's this very simple thing. So give me just a second while so you can see it. Okay, so there's that. Now I'm going to go over here to Elm Reactor. So as I said, Elm Reactor starts up a little web server here at port 8000 and shows you the status of your application. We go here to examples. We see the different examples that come with this architecture thing, and architecture application. And you can see there's these 8 different examples. So we're just going to start with the first one. So here's the first example. And you can see there's very simple UI. There's a minus, a number, and a plus. If I click the minus button, this goes down. If I click the plus button, it goes up. And it goes positive and negative. Okay, that's the application. So let's look and see what exactly Elm did in order to create this little application. So I'm going to move this out of the way, but we'll leave it right here like this. So here's the Elm application. The first thing we do is import a bunch of stuff. So this is all the basic HTML and browser interface that comes with Elm. We're just going to pull in a couple of HTML events, types. We got a button, a div, and some text. And then one event that we care about, which is the on-click event. So this is what happens when the user clicks a button. Every Elm program needs a main function. And so our main function is going to be the result of calling browser.sandbox. Browser.sandbox is a very simple version of an HTML application. You give it an initialization function, an update function, and a view function. And it does all the rest for you. Here's our model. So when you construct a model, what we want to know is we want to know what is the state of our application. So in the case of this little button thing, the state of our application is just a number. And so we're going to go ahead, so we can just think of our model as a single integer. That's the only thing that changes over time. And so we're going to use type alias. So we're going to create a type alias. We're going to call our thing a model. And it's going to be equal, it's going to be the same as an integer. And then we can construct an init function. So init is a function that returns one thing, and that one thing is of type model. And it will be equal to 0. Okay, so our model is going to start off at 0. We then create an update function. So we think a little bit, when you're constructing an update function, you ask, how can the state of my model change? And in this case, there's really only 2 things that can happen to the state of our model. It can go up or it can go down. So we're going to create 2 different messages, and the messages represent those 2 things that could change. And one message we're going to call increment, and the other message we're going to call decrement. Now notice this has nothing to do with the front end, has nothing to do with the UI. We don't know we're not saying anything about where these messages come from. We're just saying these are the types of things that can happen to the state of our application. Then we construct the update function. So the update function is the thing that takes an update message and changes the state of our application. In this case, function signature is very simple. You give me a message and you give me a model, and I'm going to give you back an updated model. So in this case, it's really easy. Depends on the message. Sorry, I'm going to go ahead and do a case statement on the message. If I get the increment message, the new model will be the old model plus 1. Otherwise, it will be the old model minus 1. This works because it's all just integers. Okay, so that's our update function. Now we have the view. Oh, and so notice, again, we've said nothing about where these messages come from. We've said nothing about anything, but this is just how we track the state of our application. Now we look at the view function. So the view function is the thing that's responsible for actually rendering the UI. So you give me a model, I'll give you back an HTML message. And so here's the model. Sorry, the view is a function. It accepts a single parameter called model, which is of type model. And I'm going to return a bunch of HTML. And the HTML I'm going to return are, each HTML element has 2 lists as its parameter. The first list is a list of attributes. The second list is a list of children elements. So we're going to create a div. Hopefully you all know at least a little bit about web programming. We're going to create a div. It has no attributes, but it has 3 children, a button, another div with some text in it, and another button. So that represents the 3 elements of our UI, the minus button, the text, and the plus button. So the first button, it's going to have an attribute. That attribute is there's going to be an on-click event. And when someone clicks that button, it's going to generate a decrement message. And then Elm will be responsible for getting that decrement message back into our application. The children of that button is just some text with a minus sign. The middle div has no attributes, but has a child. The child is just a text HTML element, and that's going to take the model and it's going to render it. In this case, it's going to just print it out as a string. The third element is another button. When you click it, it will generate an increment message, and the text of the button is plus. So you see all of that rendered over here. So when I click minus, that's generating a decrement message, and then someone is calling this update function using the decrement message and our current model, and it's updating the model. By the way, let me just, yeah, go ahead.
So those text items, are those like the first text is like the minus? Does it not have any attributes? Is that minus not its child, or is that the attribute itself, or is that something different than like a p tag or something, or span?
Yeah, it actually, if we inspect this, so if we actually look at the HTML that's being generated here, as far as I know, text is just literal text. It's not a tag. And so it's just like some literal text.
Cool. Okay.
Okay, great. Good question.
Thanks.
Nathan asks, so the model you're updating is passed into the view, and that's how it's persisting throughout the program. Yes. So Elm under the hood is keeping track of the model for us. It initialized the model, it passes it to the view when we need to, it passes it into the update function when we need to. Elm is doing all of that routing for us. Okay, let me just show you something else that's kind of fun. Since we are using this thing called Elm Reactor, we can change things in our source code, and as soon as we change them, it automatically recompiles and like refreshes the browser and all that. Or sorry, it doesn't refresh the browser, but automatically recompiles for us. So for example, we can change this maybe to minus and change this to plus. I'll save my code. As soon as I've saved it, Reactor goes ahead and updates it. And now if I reload it here, everything has changed for me. So Elm Reactor is kind of nice for quick and dirty Elm debugging. Okay, cool. Let's see a slightly more complex example now. Well, first of all, any questions about this? We're good? Okay. Now, hopefully, as I'm going through all of this, you've all looked at the lab spec, and you're all thinking to yourselves, how can I make a tic-tac-toe application using this framework. And hopefully you're asking yourself questions like, what would the state of a tic-tac-toe application be? We'll go through that a little bit kind of towards the end of our lecture today, when we tie this all together. But for now, excuse me, let's look at a slightly more fun example. So if you want to, this Elm architecture tutorial has a lot of really good examples that you can have fun with. I particularly enjoyed this JSON one. Oh no. Oh. I'm sad. Nathan asks, what's the URL? I think if you just Google Elm architecture tutorial. Here, let me try that really quickly. It's this one right here. Evan CZ, Elm architecture tutorial. Does a really nice job of going through several examples of the Elm architecture. Oh, I'm sad. So this other example, which doesn't seem to be working right now, is a random cat example. And it was really cool because it lets you download random cats from Giphy.com. Hold on though. Oh yeah, okay, let's see. Taylor has given us a little link here. Let's see if we can. Yeah, it seems to be totally broken, Taylor. I don't know why. I'm guessing, Taylor, I don't know if you want to take a look at this for me, but I'm guessing it has to do with the fact that there's an API key here. And I'm wondering if like we've maybe exceeded, like maybe I have exceeded the request rate or something like that. I don't know. Hold on. Okay. I really want you guys to see this. So we're just going to try hacking here for just a second. No. Oh, I'm super sad. Let's see. Does somebody want to quickly see if we can get an API key for Giphy.com? Okay, Taylor asks, would you like me to show it on his screen? Actually, yes. Can you do that? Can you take over screen sharing? Okay, we're gonna see if we can all see. Do I need to stop sharing? Here, I'll stop sharing. Okay, Taylor is showing his screen. Okay, hopefully y'all can see this. Thank you, Taylor. So the idea is that when you click the More Please button, it will pull in a random This is why I wanted you guys to see this. To me, this is infinitely amusing. Go ahead, Taylor, click it again. It'll just pull in a random cat picture. And I don't know, maybe you guys don't find this as entertaining as I do, but I sat here for many minutes and requested many of these things. They're just so adorable. So this is a very simple little application. You click the button, it gets a new random animated GIF and just like keeps doing its thing. Okay. Oh, we already saw that one. Interesting. Okay, Taylor, go ahead and maybe you can stop sharing your screen and we'll go through go through. Okay, I'm going to share. Let's go through the code. So now we know how that was supposed to work. Oh, I guess we don't actually need this. So let's go ahead and go through this is example 6. So cool. Okay, so here's the code. Hopefully you all can see that. Here's the code for this very simple little entertaining cat picture generator. Okay, so there's a couple new things here, and some of them I don't fully understand, so we'll just go through it though. I'll tell you what I do understand, and I'll skip the parts I don't understand. What I don't understand is subscriptions. I just haven't learned about that yet. I don't know what that is. Okay, a bunch of imports at the beginning. We are importing some attributes, events. We're also importing this thing called HTTP, which is the thing that's going to let us make remote calls to the Giphy server. And then we've got a little JSON decoder that will help us decode the JSON responses that are going to come back from the server. Okay, so the main function here, again, we're just going to use this simple browser thing. You give me an init function, an update function, this subscriptions function, which we'll see if we can figure out what this is together in real time in just a few minutes, and a view function. So here's our model. So the model, the state of the system is a little more complicated now, because now we're thinking about this asynchronous thing, and the state of our system is, well, did you fail to load something? Are you currently loading something? Or has something been loaded? And if something has been loaded, then what was the thing that was loaded? Like, what's the actual URL of the thing, of the picture? Notice that the picture itself is not part of the application state. The picture itself, that'll all be rendered on the browser. Like the browser, that's part of the view. In this particular design, that's not part of the application state. Okay, so init, so you give me, so this is a slightly more complicated version of the init function. And I believe that what this is doing is, I actually don't know what the first parameter here is. It's an empty parameter. So I think that means it doesn't matter what it is, or it's ignored. But my init function is actually going to return two things. This is, I think, the more general version of init, where it gives me an initial model, and then it gives me an initial message that is applied to that model. So it kind of gets things going. When we load up the application, you might have noticed that as soon as you load it up, even before you click any buttons, it goes ahead and starts loading cat pictures. So we're going to return a simple model. The model will be in the loading state, and we're going to return a message, which is get random cat gif. Okay, then here's updates. So let's think about the kinds of updates now. So in this application, we have two asynchronous types of things that can happen. The first thing that can happen is that the user can click a button, and that button will say, please give me another picture. The other thing that can happen is we can get a request back from the network, which is the Giphy server has given us a URL, and we want to go ahead and update our UI to change the image. So that's reflected here in these two messages. More please, this is coming from the user. It's when they click either the try again button or the more please button. Got GIF is when, that's when we get a result back from the server. And you can see that it's parameterized with a couple of things. So we have an error and maybe a string, as well as a result type. Okay, so how do we update? Well, the update function is pretty straightforward here. Remember, there's only a couple of different states that our model can be in. So you give me a message and a model, and I'm going to return a model, and I'm going to trigger another command. So this lets us sort of chain commands together. So there's really only two messages. if you give me the more please message, so someone clicked the button, I'm going to transition to the loading state, and I'm going to generate a new, sorry, I keep beeping here. I'm going to generate another message, which is the get random cat GIF message, and that will trigger, that's a function that we'll call. If I actually got something back from the server, there's two possibilities. Either it was okay, in which case we'll go ahead and update the state of the model to be in the success state, and we'll get the URL of that thing. Otherwise, if it was an error, then we'll update the state of the model to be in the failure state. So this is just showing the logic of how we transition between loading, okay, and error. Again, this has nothing to do with the view. Subscriptions, I really don't know quite what this is doing. I don't know why we need it. Yeah, so sorry, I can't help you with that. But you don't need it for your tic-tac-toe. And then finally, here's the view function. So the view function, we're going to take, oh, Taylor says he could explain it briefly. Please, that'd be great. Thanks, Taylor. Taylor, you might be muted.
Am I on?
Are you trying to talk? I can't hear you.
Hello, hello. Can you hear me now?
Hold on, let me turn on my speaker.
Can everyone else hear me?
Okay, I'm sorry. Now I can hear you.
Okay, great. So basically subscriptions are kind of like adding more things that can come into the update function for the for the application. So like by default, your application is subscribed to the user's actions from the interface. So like when you click on a button or something, it creates an HTML message. So subscription is like, we want to also get events from other things besides the user. So in this case, we're getting a, well, I guess in this case, we're not actually subscribing to anything, but if we wanted to, we could subscribe to say like a WebSocket or something like some other event that could happen that is not necessarily from the user. So,
okay, yep, cool. That makes perfect sense. Thank you. So can you explain the syntax here? So we've got a function called subscriptions that takes as input a model and returns none. I mean, what is this subscribing us to in this case?
yeah, I haven't done a whole lot with it, so
Okay.
I would have to look up more about that. But I know the general idea is that it's other events that can happen besides user interaction. And as far as like the syntax and like what things you can subscribe to, I'm not super certain on. But
okay.
Yeah.
All right. Cool. Well, thank you. That helps. Okay, let's quickly go over the view function, and then we want to flip over to the lab. So the view here, so you give me a model, I'm going to give you back some HTML. It's very simple. I give you a div with no attributes, a couple of children, including the text random cats at the top, and then a little thing where I actually view the image. This is just a factoring it out a little bit. And here's where we take the 3 different cases of our model into account. So you give me a model. If your model's in the failure state, I'll render some failure text. If it's in the loading state, I'll render some loading text. If it's in the success state, then I'll go ahead and render a button as well as rendering the image. And then down here, there's just a little bit of logic for how we actually download the cats from getRandomCat GIF actually gets the URL for it, and then this decoder just takes a JSON thing and pulls out the URL. Anyway, this is not as important. We only have a few minutes left, so what I'd like to do is I'd like to go back to my desktop, go back to our presentation, and just show here the very last The very last image. Okay, so this is what we want your final lab to look like. So the idea is you need to keep track of the tic-tac-toe game, the state of the tic-tac-toe game. So what is the state? Well, the state is whose turn is it, and what is the status of all of the 9 buttons. And remember that for each button, there's 3 different values. It could be X, O, or no one has played there yet. So we want your application to look like this when you're done. Let me just show you really quickly, since we're out of time. We have exactly 2 minutes left. So let's go to the lab spec. So now that you understand where we're headed a little bit more, hopefully the lab spec makes more sense. If you look at the lab basics, we've got a couple of simple files to get your project bootstrapped, and then lab9.elm, this is where you're going to put in your code. So now this ought to look a little bit familiar. Here's those basic imports. We're using the browser sandbox. Here's where you would actually stick your model. So this is where you're going to keep track of the state of your tic-tac-toe thing. Here's where you think hard about what kinds of updates could happen, as well as how to update your model in response to those messages. And then here's where you actually render the HTML for your application. Okay, so hopefully that's pretty straightforward. I'm sure you'll have questions. I'm sure our amazing TAs will be happy to help. We have about 30 seconds left. Is there anybody that has a question right now? Okay, then good luck everybody. Have a great day. We'll call it there, and I'll post this lecture as soon as I can. So take care, you guys, and we'll see you on Friday. And thanks, Taylor, for your help.